Could you at any point envision that the finish of our universe may be the start of the next one? Maybe even one that is altogether unique in relation to our own? Speculations of the multiverse are nothing new in the universe of astronomy, yet proof for this hypothesis is arising. The James Webb Space Telescope has recently delivered the first picture of another universe. Since the earliest days of recorded history, people have gazed upward at the stars and contemplated the sun, the moon, and the stars. For the earliest people, the sun and the moon were openings in the sky through which light came into a world that these individuals envisioned as a disk. Over centuries, our species has found that we live on a ball that pivots and spins around a star, which is likewise a circle along with quite a large number of different stars and planets. We are a small part of an enormous universe and an even bigger universe. Despite the fact that we have had powerful telescopes for around 100 years, we still don't know it all about space. Specialists are continually finding more peculiarities in the universe. They find answers to old questions, yet numerous secrets remain. Strange, right? Until now, we don't have the foggiest idea who made the universe or why. We didn't know until recently whether the universe has an end or is perpetual. With our best telescopes, we have so far been able to see around 13.3 billion light-years away. When we look, we are continuously thinking back in time because the light that telescopes like Hubble catch has traveled through existence to reach us. We see the picture existing apart from everything else when the light started its journey to us. This investigation into the past is captivating. Thus, specialists had the option to think back nearly to the introduction of the universe, or at least that is what they thought for quite a while. Then came James Webb, the new space telescope from NASA, the Canadian Space Agency, and the European Space Agency (ESA), which started operation in the summer of 2022. Even the first pictures from the telescope provided sensitive material that ignites heated conversations among researchers today. To be accurate, there are 6 universes that should have existed at the dawn of mankind for which there is no logical explanation. Systems like Glass Z13 previously existed 250 to 350 million years after the Big Bang, and that is theoretically unimaginable. At this particular moment, there should have been only a couple of stars gradually coming together to form whole galaxies, and a few billion years would be essential. What does this mean currently? Is the hypothesis of the Big Bang wrong? Or is there a totally unique explanation? For sure, there is one. We might check out another universe. Here, the picture of the system group max J0647 plus 715 uncovers a stunning perspective of a gathering of systems, like valuable pearls shining in the vastness of space. What really excites researchers about this picture isn't just its beauty but the facts. The same region of the universe was already imaged 10 years prior by the Hubble Space Telescope. However, the quality of the picture wasn't quite as useful, and specifically, the old and ruddy objects behind the scenes couldn't be decoded. It was only clear that they existed, and that was odd enough. The gravitational lensing effect, where small and distant objects in the background are amplified by objects in front, let specialists know that these obscured points of light were old and extremely old. For sure, James Webb then uncovered staggering new details due to the triple lensing effect. Galaxies so old, so bright, and so highly organized that our Milky Way seems rather ordinary in comparison. Today, specialists are especially baffled by the information on brightness power. If the translations are right, these galaxies have created multiple times more stars than our galaxy. All the principles of astronomy fail. It's as if researchers have built all cosmological perspectives around an assumption that now clearly turns out to be misleading. This is a shock for those who believed in the existence of a single universe and expected that everything inside this universe could be explained with the scenarios of Einstein's theory of relativity. Meanwhile, different branches of physics have long proposed that it's significantly more logical for us to live in a universe that is only one of many, with numerous additional aspects or universes that could exist alongside or even within our own reality. These systems could contradict our current ideas since they belong to a completely different universe and exist within a completely different time structure. One of the first newfound systems was Glass Z12. Worlds are typically named after the observation frameworks through which they are found. Glass represents gravitational lensing accurate redshift survey, and Z12 denotes the value of the redshift. Each observation group uses somewhat different designations, and providing the redshift value of a newfound universe is not mandatory. Universes can also get straightforward mathematical designations. To laypeople, Z12 may sound unremarkable, but astronomers hold their breath with this designation. This value means the system already existed 300 to 400 million years after the Big Bang. Therefore, it's actually old and, according to current cosmological hypotheses, seemingly impossible. The discovery of glass Z12 was already celebrated as a sensation in the academic community, but even more ancient and curious galaxies followed. The universe candidate CRS 93316 appears to top all the irregularities. This object is so old that it previously existed 250 million years after the Big Bang. However, this object shows another peculiarity. Measurements of redshift yielded two extremely rare outcomes. At one point, the object showed a redshift of 16.7 Z, indicating extreme age. Then measurements of nearby objects to CRS 93316 were taken, and based on those, the galaxy showed an entirely different redshift. The universe appeared as though it existed in two places and two times simultaneously. Researchers playfully refer to this system as Schrödinger's galaxy, inspired by the famous quantum physicist Erwin Schrödinger, who demonstrated that, at the quantum level, at least two realities can exist simultaneously. According to these hypotheses, it's not just possible to have two universes, but there are potentially countless more in various and infinite forms. Researchers trying to wrestle with these measurement results and known aspects would still like to believe in a measurement error or even doubt whether these points of light are galaxies at all. While the spectroscopy assessment to confirm the redshift is still ongoing, further data analysis from James Webb's IR camera system has already completely ruled out the possibility of it being a low-mass star or an unobserved active galactic nucleus. We should guess that the discovery of CRS 93316 was just the start of what is possible. NASA has suggested that the James Webb Space Telescope, hypothetically, can detect galaxies with a redshift greater than 20. These galaxies would have existed just 200 million years after the Big Bang, or maybe the telescope is looking much further into aspects of our universe, which may confirm that we have encountered a limit of existence unrelated to the Big Bang at all. As of now, we can no longer speak of the dawn of mankind, the universe, or the time after the Big Bang. Rather, we change the phrasing and refer to it as the edge of the observable universe. There lies another intriguing source of light, which shows an extremely high redshift value in our images to demonstrate that a 2744 Y1 is indeed a galaxy whose light has traveled more than 13 billion years to reach us. A group of scientists has combined the best telescopes in the world. The Spitzer telescope, Tundra, and Hubble have captured another image of this surprising galaxy by gathering data from various frequencies of light and combining them into one image. Not only is the age and distance of this galaxy captivating, but the rate of star formation exceeds anything previously considered possible in physics. Despite being multiple times less than our own Milky Way galaxy, a 2744 Y1 produces stars at a rate that is several times faster than that of the Milky Way, which is unusual for a galaxy in a young universe. The observable universe currently has a radius of 46.1 billion light-years. Beyond that, there is probably substantially more. The better our technologies become, the further and more detailed our observations can reach. James Webb is hypothetically capable of looking back 13.6 billion years. If the Big Bang happened 13.8 billion years ago, there would eventually be a limit to our observations. This is because a few hundred years after the Big Bang, the universe would have been completely dark. The first stars are believed to have formed only after 380,000 years. If astronomers continue to find even older galaxies, it will undoubtedly show that all previous cosmological assumptions were incorrect. Currently, researchers at NASA are gaining initial insights with the new telescope, which have already been astonishing. However, we know that time generally brings new insights, and in a few years, researchers could possibly extract even more from the telescope's capabilities. Then maybe we could finally see what really happened at the so-called start of time. Although the hypothesis of the Big Bang seemed plausible for a while, there was no proof to support its accuracy. With the rise of quantum physics, it became significantly more likely that our universe is an incredibly variable, diverse, and potentially complex place. Models of the bubble universe or pocket universe suggest that our universe is encased in a huge bubble and shares space with many other bubbles of different sizes. The pocket universe posits that within a universe, there are different fragments where similar yet also different states of being may persist. These pockets could provide access to different aspects or corners of the universe where various regulations apply. There are just as many pieces of evidence and hints for these speculations as there are for the theory of the Big Bang. The assumptions of the Big Bang and the principles of Einstein's physics were established long before the speculations of quantum physics. In the future, the integration of these models could lead to a deeper understanding of our universe and the multiverse. If this turns out to be true, then we may be living in a bubble universe surrounded by different bubbles, or there could be an infinite number of universes, each with its own set of physical laws. This would imply a level of complexity that goes far beyond our current understanding of the universe and our place within it. As we continue to explore and uncover new data, the possibility of finding alternative universes and aspects becomes increasingly plausible, potentially reshaping our understanding. We might interpret reality itself in a new light, delving further into the implications of these new cosmic revelations. We need to explore the broader questions they raise about our universe and our place within it. One of the most significant questions is whether the universe we observe is all that exists or if our observations merely reveal a much larger and more complex structure. The idea of a multiverse, that various, maybe endless, universes exist beyond our own, has gained momentum in both theoretical physics and cosmology. If the recent discoveries made by the James Webb Space Telescope suggest the existence of galaxies that defy current understanding, it may be a sign that our universe is merely one part of a much grander, infinite tapestry. The multiverse hypothesis itself comes in different forms, each with various implications for our understanding of reality. One notable hypothesis is the inflationary multiverse, which suggests that during the early moments of the Big Bang, different regions of space expanded at different rates. This uneven expansion could have led to the creation of numerous distinct bubble universes, each with its own set of physical laws and constants. If this hypothesis holds, then the universe we see may be just one bubble in a vast, diverse cosmic foam. Another intriguing concept is the possibility of a cyclic universe. This hypothesis proposes that the universe undergoes an eternal cycle of creation, expansion, contraction, and rebirth. According to this model, the universe as we know it could be the result of a previous universe collapsing in on itself and then re-emerging in a Big Bang-like event. This cycle could hypothetically repeat endlessly. It is only one way to suggest that our universe cycles through an infinite series of cosmic resurrections. The discovery of incredibly old galaxies like Glass Z12 and CRS 93316 poses significant challenges to our current understanding of cosmic evolution. These discoveries imply that there might have been processes occurring in the early universe that we do not yet fully understand. If galaxies could form and organize themselves so rapidly after the Big Bang, it suggests that our models of cosmic evolution and the formation of structures in the universe may require substantial revisions. This revelation could lead to new theories about how galaxies and other cosmic structures develop and interact over time. Additionally, the possibility of observing anomalies that seem to defy standard models of physics opens the door to a reassessment of fundamental principles. For example, the existence of galaxies with properties that challenge our understanding of dark matter, dark energy, and the behavior of light could necessitate a revision of the standard model of particle physics. This could also prompt a reevaluation of Einstein's theory of relativity and how it applies on the grandest scales. As we continue to push the limits of our observational capabilities, the role of future space missions and next-generation telescopes will be crucial. Instruments that are even more powerful than the James Webb Space Telescope will be needed to probe further into the universe and potentially detect even more distant or faint objects. These advancements will help refine our understanding of the universe's history and structure and may provide more clues about the true nature of the cosmos. Moreover, the philosophical and existential implications of these discoveries are significant. If our universe is part of a multiverse or if there are domains beyond our current observational limits, it challenges our very understanding of existence. This could impact not only scientific theories but also our philosophical and spiritual views on life, consciousness, and the nature of reality. As we unravel more about the universe, we might find ourselves reevaluating fundamental questions about the meaning and purpose of our existence. In summary, the new insights gained from the James Webb Space Telescope and other advanced observational tools are expanding our knowledge of the universe in ways we had not anticipated. These revelations are not only adding new pieces to the cosmic puzzle, but are fundamentally reshaping our understanding of the universe. As we continue to explore and learn, we stand on the brink of potentially groundbreaking discoveries that could transform our view of reality itself. The journey to understanding the true nature of the universe is far from over, and each new discovery brings us one step closer to unraveling the mysteries of existence.